I've wanted to dig in and figure out how all of this works and look at, just using different data sources, like how the best practices of using historical data in this would work. Like I said, I didn't get through the last one, so I'm not sure what was on your schedule today, but I did want to join and learn.
Yeah, I mean, to be honest, we want this to be an interactive workshop to get through whatever, whoever shows up, whatever questions they have. So I'm happy to zoom into that. And I'm also going to open the floor. Actually, I'm going to give everyone the ability to chat here. So I've opened up to the rest too. And there's someone else here too, Zoom Benutzer, if you'd like to also raise your questions right now, and then I can focus the discussion around the questions from you and from any Siri. So if you have anything that you want to raise, otherwise what I'll do is I will dive into some of the stuff we've been doing on modeling and whatnot. Okay, so I guess we didn't hear from them. So any Siri, I will jump in and just describe to you some of the stuff we've done from the modeling perspective. So overall, some of it, we've put it directly into PDR backend already. And if you look into PDR backend, from last week, I described how there's subdirectories for different agents. So there's an agent, we have an agent called dfbuyer, which is for the predictor data farming that goes live in 5 weeks. And basically what it's doing is it's simply buying tokens every now and then. Oh, hi, and it's Malta here for Zoom Benutzer. Great, cool. Malta, you've also been unmuted audio-wise, so if you wanted to say anything there too, that's fine. But also nice that you're chatting, so nice to have you here. Oh, wait, here we go, yeah. Okay, so I'm just gonna keep going through, and if more questions pop up, let me know. So dfbuyer is an agent that simply, it's how we've implemented prediction data farming. Specifically, how did it zoom? Okay, still. Fighting with technology. Nope. Here we go. Okay, so dfbuyer is how we implemented data farming, where it's simply buying feeds periodically. Predictor is the predictor agent. Publisher is not really an agent. It just runs to publish the feeds in the first place. Trader is the trader agent. TrueVal is the TrueVal agent. So any Siri to your question, this is within the predictor agent. So the predictor agent, good predictor agents use AI models from historical data, et cetera, like you had hinted at. And that's within approach 2. Approach 1 is simply random, right? It's just enough to get going to show you sort of a bit of scaffolding and stuff of what that looks like. And approach 2 is, does the model building and whatnot. And we actually have 2 versions of approach 2. There's the version that I can pull up right now, and that's a static model. And there's a version with dynamic modeling where the model is built on the fly. And that way you don't have to have a pre-saved model, et cetera. So the static model, if you zoom into this, it shows where this was grabbed from. And this is actually a different directory where we, in fact, I'll go, a different directory. That's in fact a different repo itself. So I'll just show what I mean by this. So going through the README, we talk about the model-based approach. It's using AI ML models, and it's this main 2.py, which is what I have right here. It's using predict.py in the same directory, and that imports from the PDR model simple repo. So it's getting a model from a completely different GitHub repo called PDR model simple. And so it imports that, and then once it has that imported, then it can treat it like to do Python function calls and stuff, right? So basically, we can get into that. So I'll go to PDR model simple repo. And this actually gets into a lot of the details of historical modeling and so on, right? Let's see here, fighting with tech again. Okay, so within it, it also lays out how you can make models and stuff that way, right? And a lot of the models we've built, we've actually had pretty decent success with simply historical data. from prices. And we typically this is OHLCV, this is candles over 5-minute intervals. So, OHLCV is open, high, low, close, volume. So in a given 5-minute candle, what was the opening price? What was the highest price? What was the lowest price? What was the close price at the end of the 5-minute candle? And then what was the total trading volume within that candle? And a good starting point to get that data is something called the CCXT library. And it's pretty shockingly good. It's very thorough. This library, I hadn't heard of it. I don't know, a year and a half ago or whatever, and we started playing around and with it. And yeah, it's quite remarkable. It's got basically connections to all of the leading exchanges out there. So here's it's the certified cryptocurrency exchanges. So there's Binance, there's BitMEX, there's Bybit, there's KuCoin, there's OKX. So a lot going on there. And then within this, there's even more going on, the Kraken, et cetera. So there's a lot going on. Within that, there's a whole bunch of data, including the OHLCV. So that's what we're using right now is just OHLCV here. And in this case, it shows how to use it. You can just say which exchange do you want, Binance, which pair, Bitcoin USDT, for example, which time frame, 5 minutes, and then you specify all that, and we've got it set up where you can train on it, right? But you can zoom into this as well and basically build it. So that goes inside Ocean model here, and it's going to grab this data. So if you look at this, where do we have it? So, in this case, the model itself is learning from the data. So this particular code, it's basically, generally learning from the CCXT data, and that's all, right? And then we've got the dynamic stuff, and we're in the process of porting that over, but I'm just going to go straight to it because it's not done yet. So there's a PR to do this, to replace approach 2. So what I'm showing you, what's there now, and it'll be there for the next week or two, is approach 2, where it's a static model. But and that's useful for you to play with. Look at all that. I encourage you. And it's against this repo PDR model simple. And at the heart of it, it's historical data of OHLCV data from the coin, from Binance typically. This one I know better because I wrote it, and in the heart of it, basically when you run it, you can also play with this, so let's just dive into what it's doing. So you can do run trade, and you set up inside it. I'll make this even larger here. You set up inside it, and you set up the data that you want to grab. You set up the model training. You set up trading parameters, and you set up a strategy. So in this case, the data that I can grab is you can choose of the OHLCV data. You can choose I only want to have closed data, or I want to have all of it. You can choose which coins, and all the coins are against USDT. In this case, actually, sorry, true USD in this case, but you can have that true USD, you can have a USDT, whatever. So in this case, it's training a model based on ETH, true USD, closed data, and Bitcoin, true USD, closed data, and just in Binance. You could have this Binance comma Kraken, and then it's going to have the Binance data too. So in this case, it's a relatively small amount of data, right? It's specified just close, just the 2 pairs, just on 1 exchange. But you have it on 2 exchange, and suddenly you have 2 times more data. You have it on OHLCV, and now you've got 5x more data. You have it on maybe the top 10 tokens, you've got another 5x more data, right? So you can quickly increase the amount of data here. And then when it does, it takes that and it says, okay, in this case, it's an AR model, autoregressive. So it's looking back at the last, not just T-1 value, but also T-2, T-3, T-4. And it's treating each of those as another input, right? And that's what it's doing, let's see here. Here we go, NT. So in this case, it's T minus 1, T minus 2. But you could go T minus 1, T minus 2, T minus 3, all the way to T minus 10, right? And that's what this is about. And you can also choose where do you want to have your starting and ending timestamps. So you can say train from, from September of 2022 to June of 2023, right? So this is how we set it all up. This is one, particular setup, but it gives you a feel. So once again, I can summarize. It's autoregressive data, it's OHLCV data, historical, going back, years or just months if you want, and whatever pairs you want to train on. And then you choose what to predict. In this case, it's saying, I want to predict on Bitcoin, right? So you can predict Bitcoin. It's a function of previous historical prices of ETH, Bitcoin, et cetera, et cetera, et cetera. So yeah, I probably answered that more thoroughly than needed, but yeah, that gives you a feel for what we have. We've played around with other things with some degree of success, but nothing amazing yet. Things like sentiment data, for example. And a bit of non-autoregressive approach too. For example, we take rather than just looking at it autoregressive here, you can look at simply T minus 1. That doesn't do very well at all. You can look at a bunch of financial indicators. Things like you can just say, okay, get the price, T minus 1 price, get the moving average, get volatility, get a bunch of other indicators, and then use all of that to predict the next price. And that tends to do okay, but the autoregressive stuff does better. So, okay, so that's a question. Yeah, so any Siri, does that answer your question? Let's see here. I'm going to see if I can unmute again. There we go. So I hope I answered your question. You did. Okay, great. Thanks. And yeah, Christian had asked, is the code that was used to build the model and PDR simple, it's also public? And the answer is yes. I have one more person here. Welcome to the person who just joined, Krieg DK. And I'm opening the floor to you too, Krieg DK, if you have a question. Anything you want to ask. This is meant to be interactive, question-oriented, whatever. So yeah, if you have any questions, fire away, or anyone else too. And this includes people from Ocean Core team too. Anyone who has any more questions, go ahead. Veronica asks, I wanted, yeah, someone else? Okay, then Krieg, yes, I have muted you for now, but if you wanted to speak, just let me know, just do it. You can enter the chat and mention you want to speak. Veronica, yes. So you wanted to ask how someone becomes a predictor, and then also how do people contribute a feed? So on the first question, how does one become a predictor? So the blog for Predictor lays this out quite nicely, and I will quickly go to that. So in the table of contents for the blog, there's how to earn as a predictor, and it walks through the key things. So, and I'll just walk through the key steps. The first thing is just play a bit with predictor.ai, because the website, it'll just help you build your mental model, help you to understand what's going on. There's 10 feeds for 5 minutes, 10 feeds for 60 minutes. And then you, if you really want to get into it, you want to practice on predicting, you could do the challenge data farming. And that's, allows you to practice, simple one-off predictions, right? And challenge data farming, it's also quite straightforward to do. And they are weekly as well. So you can go through the challenge data farming README and submit. So the prize pool is 5,000 Ocean per week. And it's distributed among first, second, third as follows, 2,500 and so on. And with it, the main thing is there's a small library to install to help you do what you're doing. But basically, it's telling you, at the end of the day, you have to come up with a list of 12 values, predicting the values and you have to submit right before midnight on Wednesdays. So then on Thursday morning at 12, you have to predict the price of ETH at 12:05, at 12:10, 12:15, all the way up to 1 o'clock a.m. And it's pretty straightforward to submit. In this case, you're doing it on Polygon's testnet, Mumbai. So once you've got those predicted values, and we have several examples, once you've got those predicted values, it has some code that can tell you, what's your error, and then you can publish predictions, and it's got some off-the-shelf code for this too, using Ocean libraries to publish and share using Ocean data NFTs. So that's the next step you would do to become a predictor, is just practice, right? And by the way, within this PredictETH, you might ask, okay, well, how do I actually build models? It actually has many really good example models here too. So it's got a very simple model, and then it's got fancier and fancier models too. So there's a simple model that's got using here, let's see here, boom, 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 Prophet. So Prophet is an AI model that Facebook built, and it's pretty advanced time series stuff, but a very simple interface, right? Import Prophet, you instantiate the object, and then you declare fit off of the training data. In the training data here, we have it as some pandas data frames, quite straightforward. It shows how to make those here. And in this case, it's showing you how to grab this CCXT data, the OHLCV stuff, to create the training test data, right? So this is maybe the essence of modeling, right? So you're grabbing historical data from Binance using CCXT, you're dumping it into a data frame, and then from that data frame, you're building a model, and then from the model, you're making predictions, right? So this is one example, and this is why we do encourage people to, as a predictor, rather than just jumping out the deep end and running a predictor bot, do challenge data farming for a bit, right? Play around there, you'll get a feel for the problems, etc. And then you get to be doing a predictor bot. And that's what I walked you a bit before, actually, maybe not today, sorry. So that's the README here, where you can first install, so this is the README for running a predictor bot. You install the backend, that's this repo, it's just git clone. Installing Barge, that's a git clone of Barge, but then it'll pull in a Docker container with a bunch of services. And then it tells you how to get going locally, which means running Barge, setting up some envars. And then it first of all shows you how to run an agent that's simply random predictions. And once you've got those random predictions going, you can do the model-based stuff too, right? But by the time you get here, you probably want to have a good flow for building models and so on. So, there's a bunch of ways, of course. Yeah, and then going back, once you've got the predictor bot, once you've got some basic one going, a basic model, then you can optimize, get better, better, better. And, the more accurate you are over time, the more money you make, right? Simple as that. So that's how you get going, becoming a predictor, starting with predictor AI, doing challenge data farming to get better at the model side of things, then running a predictor bot, going through the README there, and then optimize. And then the next question that I saw from Veronica was, I see how to use the predictor website, but how can I contribute a feed? That's a very good question. So overall, so let's just go to the predictor AI website for a second. So on this website, there are feeds for fighting with tech again here. So shrink this a bit. There we go. I'm fighting less. Okay, so in this case, you can see the feeds. This is 5-minute feeds for Bitcoin, ETH, and overall the top 10 crypto tokens by market cap. And each feed is, the token versus USDT on Binance. And it's a prediction, an up-down prediction every 5 minutes, right? So right now, the prediction that is in progress is, well, the prediction that you can use right now is it's predicting Bitcoin is going to go down for 17:35, 3 minutes from now, right? And that's my time. I'm in Berlin time zone. And then the predictors are making predictions for the 1740 timeframe as we speak, right? So when 1735:01 happens, like 1 second after 1735, you'll see the predictions for 1740 pop in here, right? So that's what the feeds look like. And then if you want to contribute your own feed, so right now, like you can, all these feeds are data NFTs, Ocean data NFTs with Ocean data tokens. And we have in the PDR backend a script to be publishing these feeds. So you can go ahead and do that if you want. With Predictor.ai, we're really focusing on the feeds coming into OPF right now. OPF is publishing these, and we're really doing lots of cycles internally right now to minimize friction for people to make money as predictors and as traders. So we're doing a bunch of different experiments. So overall, you can contribute a feed. Everything is permissionless. You can submit it. It'll be live on Sapphire, all that. The things that will show up here on on Predictor.ai will be the ones from OPF, and anything you in the community come up with that we think is cool too. So feel free to share that with us. So I think that's the answer. So going back to any Siri, you had a question here. I responded on X to you about building out a commodity-based model. At some point, after I play around with OHLCV, try and figure out what that might look like. Is this maybe in your planning once Predictor launches? So I'm guessing any Siri, I'm gonna unmute you just in case. Let's see here.
I'm already unmuted. Yeah.
So do you mean commodity-based as in, is that within the realm of tokens, or do you mean for predicting things like corn futures and stuff?
Exactly.
Okay, that's a great question, actually. So Predictor is built for that for sure. We're very interested in that, right? In fact, I think it was actually pork futures that Ray Dalio got to start, decades ago. So the Predictor infrastructure definitely supports the up downs of all that. And we right now in the core team working on Predictor, we are focusing on the DeFi stuff itself. But if you are interested in getting these feeds published, we're happy to hold your hand, and then also share to the world that the world can access it, of course. And we'd love to see predictions on things like corn futures and stuff for sure, right? And then, of course, people would have to, you want to have a community of people making predictions around that. But what we can do, is if you want to go for, say, corn or pork bellies or whatever, we could also have that as incentivized within the data farming program, right? To basically have different trial balloons for things beyond DeFi, right? And definitely commodities would be interesting that way for sure. So if you wanted, just DM me on Twitter, and if there's a feed, we could start to explore that and what that could look like, and then incentivizing around that. So our main focus will be DeFi for a while, but we'll put out these trial balloons for other verticals and see where they take us, because we're quite interested in that. Commodities, energy, weather, and more. Did you have any follow-up questions on that? Okay, well, you're unmuted. If you have more, just let me know. I'm going to go to Malta here. I'll just read out loud. Apologies if this is a plain code tech workshop, so ignore Photoscope. Are there plans to add a GUI layer for no-code feed consumers? Maybe in the ecosystem, I know not focus of core team. And generally, where do you see Predictor going in terms of productification and scaffolding? So great question, very relevant. And the overall way we view it is we want to minimize the friction for people to be predictors, submitting models, etc. And we want to minimize the friction for people to be able to consume the feeds as traders and otherwise. So your question, people at predictors, if you think about it, if people are doing prediction, you're going to have to know your AI ML quite well, right? Typically. So you're going to be in the depths of code, all that, Python, all that. We could have it where people are also submitting predictions simply manually and all that, like just predict up, down and stuff. And the thing is, that's going to be very tedious for anyone spending any time with that. And ultimately, the predictions aren't going to be that great. You really have to use AI ML to have decent predictions overall. So we're not going to focus, from the predictor side of things. That's really best suited to AI ML. Maybe we'll put in the GUI stuff at some point, but to lower the friction. But it's really for AI ML people writing Python code anyway. On the trader side, it's a different story, because on the trader side, there's lots of people out there running Telegram bots right now, for example, right? That maybe haven't used code at all, and these bots, they trade on behalf of these people. We're highly interested in distributing prediction feeds from Predictor to these bots, right? Top 3 bots is a useful target for us to have. So that's definitely one. Also, of course, as a trader, I mean, you can go to the website here, and right now, right, like you can buy a feed. That's why there's a buy button on there. You buy it, and then you can have your Binance open next to you. And if it says up, you can buy if you want, right? Or if it says down, you can sell or short or whatever, right? And that's a very simplistic trading strategy. And I'm not giving advice for you, just sort of as a general macro thing. It's your own responsibility with your own money, of course. So the baseline is Predictor AI. Beyond that, things like Telegram bots. And we do envision that other people will build higher level dApps on top of this too, right? So it could be where teams build derivatives that are on top of this with their own frameworks. It could be that these prediction feeds get built into existing dApps, whether it's for loans or synthetics or options trading otherwise. All of them are useful and interesting. And I do see that maybe, there's going to be teams out there, maybe people can stake Ocean or otherwise, and then someone else can do trading on their behalf or do predicting on their behalf and so on, right? So we've made it composable already. It's all Ocean data NFTs, Ocean data tokens, ERC20 data tokens. We have, everything is already out there, open source in Solidity with the Python libraries, the JavaScript libraries, all that, so people can build what they want. Our main focus is to continually lower the friction for people to make money, right? And you can unpack that, lower the friction overall from a software developer perspective, app perspective, but also lower the friction to make money. So we're really spending time internally making sure that there's ways that people can make very good money from this stuff, right? With the predictions and so on. So that, from our perspective, that comes down to more feeds, right? That might have lower trading fees, different pairs, all this sort of thing. And then also potentially even fancier trading strategies that take advantage of futures and so on. So that hopefully helps to answer your question, Malta. So the summary is, minimize friction for people to make money in the Ocean ecosystem. And that's the main bias for us within the Predictor core team. I see there's someone else, so waiting to come in. Any other questions from anyone else? And there's someone, she just came in, or she or he, depending. So if you have questions, I will, the chat is available for you, Chi. So if you want to ask a question there, maybe go for it. Or Krieg DK too, if you're interested. So Chi, by the way, if you're interested in a question, just type into the chat. The chat's open. Christian is asking to walk through the Azure deployment part a little bit. I can do this a little bit. My colleague Barkai is the one who spent a lot more time on it, but I'll just walk through. So this is, actually I have to get an up-to-date version. Azure deployment. So basically, if you're running a predictor bot or a trader bot, you go through the README. It first of all shows you how to run locally. And then for the remote, and this is testnet, and soon we'll have it for mainnet, it shows you how to do this on Azure. And so what it turns out, to run this stuff on Azure, it's much easier if you just get things running locally as containers and then get the containers running in Azure. So that's what this is, the overall strategy of this README is about. So it first of all teaches you how to get up and running. So it has that. but also, yeah, so you first of all have to set up your repo with your envars, all that. You configure the bot, such as the predictor one or the trader one, like described. And then it shows you basically, like I mentioned, how to be running this thing locally, right? But now it's got the stuff more container-y, right? So, you can use something called PM2 to be running, and that's to be running these different agents here. Once that's one way. There's lots of other ways. But then following that, you can actually have a container image of your setup. And that's what this is about. So if you've got Docker, or you can have this Podman thing instead of that. And then once you have that agent, now you need to deploy, right? And it has links here to Heroku, AWS, Google, Azure. So lots of different options, right? And in this case, this README itself shows how to do this on Azure, right? So, and Azure is kind of cool because it's got a CLI such that it feels like you're running a bash shell, but it's remotely, right? So you first of all have to build a container image like shared above. Then you have to set up an Azure container registry. So this basically says, okay, in Azure, it needs to know that, this is Trent's container registry. And so you set that up here. This is a bash command for that. And then you take this container that you built earlier, the container with all your goodies going on, and you push that to this Azure container registry, right? So you have to log in, and then you do Docker commands. You tag this thing with a name, and then you push it to that ACR registry, right? So there's a Docker version of this, and there's also a Podman version of this. And then once you got this thing on there inside that registry, then you can say, hey, run this thing, right? So and basically that's what this is about. So it's Azure container create. So basically saying, run this thing, and now you basically got this Azure container running remotely, doing your stuff that you were doing locally before. So it's quite clean. And then you can also monitor the logs, right? And here it's AZ container, and then zooming in on the logs. So this is just, very, very high level, but it gets you going in a nice end-to-end way. So kudos to Barkai for writing this all out. Yeah. Hopefully that answers your question, Christian.
Yes, thank you.
Great.
And so I'll wait if anyone else has a question.
Go for it.
So just to clarify on the flow, so as a data scientist that wants to build their own model and then deploy it as a predictor, would they, in order to make their own model, they would fork the PDR simple model repo and replace the main.py and things in there with their own model in Feature Pipeline? And then they would deploy it with PDR backend and first locally into a container to make sure it works locally, and then they would deploy it with Azure after that.
Yeah. So the main thing, going back to the onboarding, right? You first of all play with Predictor AI, 5 minutes, 30 minutes, whatever you want. Then do Challenge DF, where you get really good at making predictions, playing with the data in a static setting, right? So this gets you used to, historical data like CCXT or maybe commodities data or whatever, right? And where it's making predictions. And then, and the cool thing with Challenge DF is that you can even do this with prize money, right? There's 5,000 Ocean prize money every week. So that way, if you do really well, you can win some prize money. But the main point of that is to get used to building models that make predictions of, 5 minutes from now, 10 minutes from now, whatever, right? And then once you've done that, then you run the predictor bot. And the steps there to drill into what you were talking about, Christian. So the order of operations is, you do the install stuff. Then you get running locally with random. That's a very basic, right? Off barge. And then locally with model based. And then but with locally running with model based, you should play with it with the existing model stuff, right? Then there's a few different options of where to go from here, right? One is to just play with the existing setup with testnet, even mainnet, right? Just get it running. The existing, template models off of Azure testnet mainnet. And I'd recommend that first, honestly, personally. And then once you've done that, then go back to local and start having a better model yourself locally. And this is where the forking comes in, right? So you would fork PDR backend for yourself, or some other thing like you can, however, but that's going to be the easiest. Fork it for yourself, and then with that, you change things as you want, right? So it could be right now we've got this model-based approach where it's using a model in a different repo, right? PDR model simple. So you could use that flow, or you could use the flow where you, and in that case, you wouldn't actually need to fork PDR backend, right? You just have a different repo. You fork that repo, whatever. Or you can just fork things directly. Like we're going to be changing approach 2 where it's dynamically building the model. And then once again, you would be forking PDR backend, right? So there's quite a few different things, but it's really set up such that you get used to all this stuff first, right? You get used to the mental model of Predictor via Predictor.ai. You get used to predictions in general by doing the challenge data farming, like I covered here. Then you get used to Predictor itself by the READMEs using the off-the-shelf approaches, going from local to remote testnet to remote mainnet. And then you combine your learnings from before, right? You combine your model building learnings with how to run these bots. And then, you know, that's where the forking comes in or otherwise.
And
Okay.
so just to summarize again, so first you kind of learn, you play Predictor, and you first learn how you're using Predictor and deploying a model that's generating random predictions. You get that working, you understand how that works. And then you move up another tier. So you're using our Ocean provided model, and then you're using Predictor generating predictions. Then once that's working locally, then you go to Azure. And so now at that point, you've deployed the model, like generating predictions like automatically, and it's using our Ocean provided model. And then once you're up in the 4th tier, you'd move on to like swapping in your own model instead of the Ocean provided one.
Yeah, that's not quite the order I'd recommend. I mean, it would work, right? I recommend, first of all, just playing with the website, right? Just buying tokens there and then, you know, seeing how that feels, right? What it looks like, right? Predictor.ai. Then challenge DF, it's, you know, independent of Predictor itself, but the problem is similar in structure, right? Because you have to predict 5 minutes ahead or 60 minutes ahead, right? So you do that, and by going through that, you are interacting with the chain, but most importantly, you are playing with making predictions, time series predictions in token land, right? What's the price of ETH 5 minutes from now? So it forces you to, you know, play with TCXT or whatever else, make models, make predictions, and there's even some money on the line if you want it there to be, right? So that gets you quite comfortable and familiar with making predictions of tokens, right? Then within the step 3, run a predictor bot. What I recommend first is go end-to-end local, remote testnet, remote mainnet on the Ocean supplied templates, right? And when you go remote mainnet, it can of course just be a small amount of money at stake, right? Just like stake, you know, 0.1 Ocean each time. So it's hardly anything, but now you're used to it, right? So now from step 2, you're used to models. From step 3, you've run things end to end, right? Including in production. Then what you do is you combine those. The learnings you had from predictions, plus running end to end in production. And that's where you would typically fork PDR backend and have your own model.
Cool. That makes sense. Thank you.
No problem. Any more questions? Chi, you've been a bit quiet. If you want to have any questions, go for it. You can ask in the chat or otherwise. Or any Siri, if you have more questions too, go for it. Any Siri, by the way, another thing too, we also, there's an opportunity to have data challenges. So Christian, who's in the call here, he co-runs the data challenges. And so just like we have these predict ETH challenges to help people get used to, you know, predicting ETH, we could potentially have a data challenge around, say, predicting corn price, right? And that would be a way to, for people in the Ocean community and otherwise to get to learn about making predictions for corn, where the feeds might come from, all of that. And then that's actually a very nice stepping stone towards putting the thing within Predictor itself, right? And yeah, we could even have an ongoing contest around that too. Just like right now we have, Challenge DF for predicting ETH. We could have another sub contest for predicting corn, right? Chi, thank you, by the way, for mentioning you don't have any question. Great, that's fine. Okay, so maybe, if there's no more questions, let's move towards wrap up. So does anyone have any final questions? Something burning or some mundane thing or some amazing question? Any of the above? Every question is amazing. Silence. Okay. Well, with that then, thank you everyone for the session and the really great questions and the interactivity. This was really nice. So with that, I'm going to stop sharing first of all, and then I will stop the call. So thank you everyone, and good luck with all your own experiments in predicting and trading and so on. Bye.